Alright guys, let's look at numbers 18 and 19. We looked at numbers 16, 17, and actually I called it 18 in our video, but it was number 20. So we looked at 16, 17, and 20, and then here we missed 18 and 19, so we're going to look at those here, and then we'll do number 28, which is a whole bunch of calculations again, and we'll do the last one on percentiles, which is number 29. Now, number 18, it says that a high school GPAs are normally distributed with a mean of 2.6. I wrote it here, and a standard deviation of 0.5. Again, it doesn't matter if it's sample or population here. To be honest with you, the difference between sample and population for standard deviation and variance is really going to come into play when we get to module 6. When it comes to using them to do other calculations, it really doesn't matter which one you use. Unless otherwise it's specifically asking you to calculate, for example, I mean, if you look at number 28, it specifically tells you to calculate, for example, the like sigma squared, which means there I want you to calculate the population variance. So if I specifically ask you for these things, then it matters. But if you're trying to find the mean and the standard deviation to do something else with it, then it really doesn't matter if you use the sample or population. But in this case, that doesn't even matter because they're giving you the standard deviation. So, and it's saying at a high school. So you can look at them as population or sample, doesn't matter, you have them given to you anyways. So it's not even a question of talking about whether that's sample or population, it doesn't matter. The standard deviation is 0.5. Now it says what percentage of students will have GPAs between 2.1 and 3.1. Now you really don't need a spreadsheet here. It's more of a conceptual problem. I have the, that's the empirical rule, and I have it right here so you can look at it. And if you recall, all you have to do is to determine if your values are plus or minus 1 standard deviation away from the mean, then that means you capture 68% of the population, and that's what it's asking you, what percent are between these two numbers. So all you have to do is figure out how many standard deviations are 2.1 and 3.1 away from the middle. And if it's 1, then you say the answer is 68. If there are 2 standard deviations away, then the answer would be 95. If there are 3 standard deviations away, the answer will be 99.7. So if I did a little diagram for you here, I have the average as 2.6. I have the standard deviation as 0.5 in both direction, left and right. So if I go 1 standard deviation to the right, half a unit from 2.6, I'll get to 3.1. And if I go half a unit from the average to the left, which is 1 standard deviation to the left, I'll get to 2.1 because 2.6 minus 0.5 is 2.1. So you see, I can get to these two values with only 1 standard deviation move, which means I'm only away 1 standard deviation. So the answer here is 68%, because I am 1 standard deviation away from my average. So 68% of the college students have GPAs between 2.1 and 3.1. Now for number 19 is the same as number 20. They're giving us a value of x, which is 13.7. They're giving us an average of 17.5 and a standard deviation of 2.1. And they're asking us to determine if this x value is usual or not. They're trying to figure out if 13.7 is usual or not, and in order to do that you have to calculate the z-score, as I've told you before, and if that z-score is between minus 2 and 2, then you consider it to be a usual value, and if it's a value less than negative 2 and greater than 2, then you would consider it to be unusual. So let's see if I can calculate my z-score here. And I'm just saying equals parentheses x minus mu, close parentheses, divide by sigma, and there's my z-score, minus 1.8, and that is between minus 2 and 2, so you say the value is usual, and that is the answer for number 19.